Welcome to a new video in the Design Pattern course. In this video, we will be discussing the Builder pattern. Builder is a creational design pattern that lets you construct complex objects step by step. The pattern allows you to produce different types and representations of an object using the same construction code. Imagine a situation where we need to create an object with many parameters, but we don't need all of them in one instance. Essentially, the creation logic is complex. This can become a significant issue when handling such logic in your code. In this example, we are going to use a sample object character with parameters like name, age, and weight. We are not creating a constructor class. Instead, we will use our node as constructor, and we try to keep as simple as possible. I'm implementing this builder pattern using GD script. And in this video, I am showcasing a UML diagram that represents the final result. First, I started with the character class, which includes the variables name, age, and weight. These three variables will be used throughout the implementation. We will initialize the character class using a constructor that takes name, age, and weight as parameters to assign values. Basically, init serves as a constructor in GD script. Next, I created a function to describe the character, which simply displays the values assigned to each variable within the class. Moving forward, we will create the character builder class. In this builder class, we will define the variables needed for each character attribute: name, age, and weight. For this purpose, we need these variables inside the character builder. Initially, I attempted to implement it using the character class itself. However, I changed my approach, aiming to reuse the attributes within Character Builder to maintain a clear separation between the two classes. First, I added a setName method to the character builder. This method assigns the name within the builder class and returns the character builder instance. The reason for this approach is to enable method chaining, allowing values to be set sequentially. Then, I added setAge for assigning the age value, followed by setWeight for the weight value. Both methods follow the same approach as setName, returning the character builder instance. Finally, I introduced the build method, which returns a character object. Within this method, a new character instance is created. Once the build method is called, I invoke the describe function to display the character's attributes. Initially, the output was incorrect due to a formatting issue when printing multiple values of different types. After conducting research, I adjusted the formatting to ensure all values were displayed correctly. Using a percentage symbol and an array of values resolved the issue. Now, when executed, The program correctly displays the name Harry, age 10, and weight 14.5. Since weight is a floating point variable, it included additional symbols. Next, I wanted to create another character, Hannah. Initially, I mistakenly instantiated it using the character class instead of the builder pattern. I then used the existing character builder to set the name as Hannah and age as 90. This time, I did not assign a weight, expecting it to default to 0. However, when I executed the code, the weight incorrectly displayed as 14.5, which was the previous value. The issue arose because the builder retained old values instead of resetting them. To fix this, I added a line to reset the values after calling build. After cleaning up unnecessary code, the issue was resolved and the expected output was displayed. Now, everything functions as intended. The builder pattern effectively enables method chaining and facilitates the creation of complex objects. That's all for this video. Thank you for watching. Please consider subscribing.